So welcome to an RVC220 from Rotel. This set in the 1990s was lent to a friend from the customer, and they managed to reverse polarity of the radio and kill it. So it's been stuck in a cupboard for 30 years and it's been sent in for service. The first couple of minutes of this video I failed to record the sound, and so rather than scrap the whole video because it's an interesting one, I've decided to overdub the first section. So open the radio up there, and there's no silly modifications, and it has come with, I think, 3 screws. So with it being reverse polarity, the two things which are likely to happen is that the output transistor for the transmitter will have been killed, and the audio IC, which in this case is a Toshiba TA7205, will also have been killed. And later on in the video you'll see when I take that IC out, it has a lovely hole in the middle of it. So the first thing's going to be, we will power it up, and that we know there's going to be no audio, and here we are with sound. So it comes to the conclusion we've got no transmit, and I'm just about to unsolder the output transistor, which appears to be the wrong one. It seems to have got a 2SC2166 in. I didn't even know that could be used at 13.8 volts without a ballast resistor. Anyway, see if we've got something nearer. So let's see what the transistor tester has to say. It says no component detected. So that's beautifully knackered, isn't it? I'm absolutely sure these are 12 volts. I don't think they are 13.8, and that's why in a lot of sets when these are in use, if you get something like a realistic walkie-talkie, which these are in the 1002s, you're not ever running those above 12 volts. Well, rephrase that, you're not ever supposed to be running those above 12 volts. And that's a 1.5 watt radio, so it's not thrashing the transistor on, it's telescopic aerial. So that when these are used in the Savinet 002F chassis, like the Mustangs and the Amstrad, we've got that ballast resistor, haven't you, that has often been linked out and has killed the transistor, and they've had 7 watts for about 10 minutes. So I'll have to just look at what we're supposed to be putting in this, but it certainly isn't one of those. There's quite a few options actually. So I'll have a look at the service manual for the Rotel 240. I'll look at that on my computer, and then we'll see what transistors we've actually got in stock. Okay, so I looked at the circuit diagram. In fact, if the printer had some paper in it, I'll just do that. So whilst the printer decides to print something, I've got 2 packets here. We've got a 2075 in, which was a lot of money, and we've got some 2075s which weren't stupidly cheap, but were cheap enough for you to think, are these genuine? And a bag and a shiny, they weren't the 50p ones, but they were cheaper than you would expect. So I'm going to put in one of those El Cheapo ones, and if it reads something like 1/2 watt output when I've done it, then it's fake. So if you look at the specification, the gain isn't going to be that much on an RF output transistor. So this we believe to be genuine. It's the writing on it is painted on, and this is going to be new old stock. It's slightly tarnished leads, and it's what you expect for a transistor that's been carefully stored for 20+ years. So it says an NPN transistor, and it says it's got a gain of 44, and that's about what you're going to expect. We'll put that back in its bag. So that's about £6. These are about 80 pence. I can't tell whether this is laser etched, because I think you're probably all aware there's lots of fake transistors around, and they seem to be good at using unmarked rejects, which were probably audio transistors, and then marking them up at whatever they feel like that day, whatever's going to fetch them the most money. So you remember it was 44 the gain on the other one. The gain's 186. You think, well, how can it be? You know, that's what starts to you to think, no, this is too good to be true. It isn't going to be like that. But that said, I'm seeing if there's a second-hand one somewhere to compare, but there isn't. So I'm going to put this dubious transistor, brand new, in this radio, and if it works, it's going to cost the customer a lot less. And if it doesn't work, we're going to be taking it back out again. Just make sure the holes are sufficiently cleared out. The last thing we want to do is to damage the print. So these are mounted on a heat pad, and then you've got an insulating screw. So we'll just pop that through the holes. Although these need to be tight, it's easy to over tighten and snap the nut, the screw even. So I won't cut the excess off, but we will have to solder them. And these printed circuits aren't the best quality. We're already losing a track there because this has been changed before. So I'm just going to check there's no short between there. So put the meter into continuity. No, there isn't. Right, we'll put the power back on. So we're now doing, we're on the low scale, we're just doing 900 milliwatts. So without tuning up anything else, well, just check that one there. And then we'll get the hex kit out. Well, I'll tell you what, that's 2 watts. So this radio is not going to do more than 1.8 watts with that transistor in it. And it's kind of, you get anywhere near 2 watts and it starts to jump back to another thing. So I'm going to take that back out. This was all going to be part of another demonstration of fake parts. Best thing to do is to cut those legs. So these work great if you only want 2 watts out of a radio. One day I'm going to make up a Cybernet 134 test jig out of a set with no front panel or something like that. So we can actually test transistors like this. We'll clean up the legs with the fiberglass brush, because this is not as clean as those fake ones, or what I think are fake ones, and what we're going to find out in a moment. Hopefully we'll put this in and it'll turn up a treat. I did buy some genuine TOSC 2166s from the United States, and they worked out about £17 each. So, you know, they don't come cheaply at all these days. So I've done the transmitter, and we're not getting much above 3 watts out of it. And what I've done is I've actually got a York 861 I can use as a test jig, and with these transistors in that set, that's doing a full 4 watts. So it's a component tolerance thing, isn't it, on this? We do see some of these which don't quite do 4 watts, and then we see some of these that when you're tuning them up they'll do 5.2. So we've plumped on having a 2SC 1909 here, and then we've got the 2114, is it? I can't, now it's in, I can't see it. So I've changed the driver as well. The gain on the driver was only 30, and these are all like 80 to 120, so that has brought it up from 1.9 watts to a bit nearer where we should be. So the other thing to do is we're going to have to change the audio IC. There's no point even saying to you, well, we'll see how it goes, because there's going to be no transmitted audio with this stuff, and there's going to be no audio on receive. I'm just wondering why the protection diode isn't there. It isn't there, you know. Sure it isn't. If it's diode 10, then it's missing. And this is model specific. This is the Rotel 220. Yep, it's diode 10, and it's missing. No wonder it, it didn't protect the radio when somebody managed to reverse polarities. By the way, he lent this a mate in the 1990s, and the mate reversed polarity in the 1990s. So this radio hasn't worked for 25 plus years. That capacitor's looking the worse for wear as well. You can see the heat shrink with the jacket, the insulation jacket with the numbers on, is receding. It's looking like it's gone for a circumcision. So we'll get that. In fact, funnily enough, I'll tell you what, we'll take that out first, and then we'll see how many of the microfarads have escaped from it. It's not often we have to change capacitors in Cybernet 134, so it's usually because of some external influence. I mean, is that contact adhesive which is underneath, or is it nastiness? So the other thing we need to do, because this can be conductive in a damp environment, is just to scrape away that contact adhesive. I'll tip that up and tip it out later. So we'll just get the ESR meter on this. So it should be 1000 microfarads. Well, it's 971, so anyway, it's getting changed. So the difficulty with this is they solder over the screw, so it does make it a bit more difficult to unsolder. Is this a candidate for that 200 watt soldering iron that Alan kindly passed on to me that I did things with? I'm not quite sure why they did this. Is it to stop you inadvertently unscrewing it? I've got to try and get a screwdriver in it. I've done it. So I've got a new Toshiba TA7205 lined up ready for this, and that is a genuine part. So with the new IC and the mica insulator is still in place, I've got a heatsink compound on the back of there, which is of course is important for it to dissipate the heat to the heatsink, and then we can put that back with its insulating screw, and these are easy to over tighten and break, and they're about 50 pence each. This particular one's wanted to go in cross-threaded. There we have that sandwich, and hopefully we can get all the pins to line up beautifully. So of course we need to screw this back in so there's no, when we solder it, there's no mechanical stress put on the printed circuit board, because we soldered it in now and then had to manipulate it a little bit to get it exactly to line up. Then that would put a strain on the printed circuit board. In fact, there weren't many CBs with fiberglass printed circuit boards really until the 2000s. That UK made Magpie Auto Scan and EMS Mercury did, but that's about it. Do we put that back, or do we find a screw out of another scrap set somewhere? Have we got any sets with any screws in at all? I'll tell you what, I think I'll go take that across to the organ workshop and I'll cut a slot with a hacksaw in so we can actually screw this back in there. So I'm going to leave that for now. Probably come back to this tomorrow. So I'll take that across to the workshop. So the next day, or is it the day after the next day, I've gone to a lot of trouble to get to the bottom of the transmit being only 2.7 watts on this radio. And you know what I think? I think it's always been 2.7 watts on this radio, because remember, this is a repair that has been reverse polarityed in the 1990s and put on one side. So it's not like it was faulty before it was killed, like a faulty car in a scrapyard that's been crashed. The battery on it might be fine, you know. So I've tested an awful lot of transistors. I've changed one or two electrolytic capacitors. I've been looking around the transmit receive switching, and nothing has improved it. I've put a new protection diode in while I was at it. That was blown apart. And then starting to clutch at straws, I've borrowed a set of 3 coils from a working set, and now the radio works. So if we look at the, are we on picture in picture, and are we in the right place? I don't think we are. I want it there. So now when I key up, helps if I switch on the radio, it's banging across to beyond 3 watts. So hopefully we can now set up the transmitter. So I'll now have to go over to the other scale. So maximum 4.1 watts, maximum 4.4 watts, maximum 5.5. Just go through this again. You've got to do this quickly so as not to burn out the transmitter, because it will not support 4.6 watts in this case for that long. So are we on channel 20? We're on channel 20. We'll still have to get the notes because I've got a memory like a sieve. I went to the doctors for my annual review. How's your memory? I said, well, it's fine. In other words, it's no different to what it ever was. And I can remember what I had for dinner today. So it's L4, we've got the set sideways on, so I don't like them sideways on. So it's L4 clockwise for 4.4 watts. Oh, I tell you what, we'll just make sure the others are right, maximum, because I have obviously been going backwards and forwards. There's a fraction more there. Can't get my trimming tool just in that one. As ever, we want this to be centered. So I reckon that this radio has never done more than 2.7 watts. Yes, we're now about 4.6. Right, so clockwise with L4 for 4.4 watts. That's there. And then anti-clockwise with that one, L9, for they say 3.8 watts, but we want 4 watts because obviously the customer is entitled to 4 watts. Just like that. So now, we'll go on channel 1, channel 14, check there, we're somewhere near. Channel 1, 4 watts. Channel 40, 4 watts. And 4 watts. Good. Wow. Also, I changed the audio IC as we left the video a couple of days ago. So those have not been killed by reverse polarity. What I'm going to do, I'm going to get another 3 out of another perfectly working set. I'm going to take the cores out, and then I'm going to look on the LCR meter, and we'll see what the inductance is of the ones which are working and these ones which aren't. Because it was just one of these that's not right. One of these is out of spec, and we don't know which at this stage. So I'm going to go to that trouble in the background. I won't be reporting back on that, but that was the way forwards with this set. Because I want it back to the customer, of course. So, the meter's probably banging across now. Boing, yeah, because it was reading where you'd expect it to be, doing 2.7 watts. So there's the meter adjustment. There's the 4. Low power is a bit iffy on this. I'll just spray that. I spotted that within my fault finding. So go to low power. We'll go to low power. I thought I'd switched it on. And there is 400 milliwatts. Switch it back to normal power. Check deviation, which is probably right. Wow, it's a little bit high, so we'll just deal with that. Now I like these adjustments in a particular place. There's the feedy backy one there. Let's get the oscillator on the job. Drop that to about there. Wow, it wants a little bit more. Wow, that's spot on now. 2.2 with an absolute maximum of 2.5. Let's see if it's on frequency. Near enough, but we'll just tweak it. 27,79125 we want. There we go. Over to the receive. So if I show you the audio IC that came out, it's got a lovely hole in it. If I just twist that around, there's a lovely hole in it where that reverse polarity's blown it up. Good. Receive. So we can hear it already. and I did just check, it's 0.78 microvolts as presented. 0.78 for 12 decibel cyanide. So just to trim the signal generator so it's spot on. Just like that. Take the camera over to the oscilloscope. Switch the bench light off. Put an S9 equivalent signal of 100 microvolts on. Turn the volume down a fraction. And check the detector. I'll put that meter away as well. That was already spot on. Right. See if we can get a bit more out of it. So, keeping it to about 4 dB, so we're not saturating the receiver. No change there. No change there. Put a bigger signal on now, just where I do these IFs. And there we are. I don't expect there's any improvement at all. The 12 dB. Oh, we've got 0.55. Well, you know, I'll go to the foot of our stairs if I had some. That surprises me. I'll show you the attenuator. I'll just show you the attenuator. Thank you. So we've got that at 1, we've got that at between 5 and 6. So that now we'll turn our attention to the squelch. I'm going to turn my soldering iron off and save 45 watts. And chances are the squelch is right. Apart from the deviation, I don't think the set's been fiddled with. Oh, we need to do the S meter, don't we? I'll just go back on that. So we've got 100 microvolts on the test set. Let's see what the meter reads. Just over the 9, so we'll just pop that down a fraction. That's S9, showing S9. Not easy to see on these sets. Back to the squelch. So turning the squelch to full. I want the squelch to open when we get to 100 microvolts. So there's 1 microvolts, 3 microvolts, 10 microvolts, 30 microvolts, 100. It hasn't opened. Does it ever open? No, it never opens. That's a really good squelch. So we'll adjust that. Now it's exactly 100 microvolts when it opens an S9 signal. So we'll do the opposite. Turn the signal generator to standby. Turn the squelch down. Set threshold on the radio. Advance the squelch. Put the signal generator back on. Advance the squelch. It's coming in at 0.65 of a microvolt, leaving it 0.48 of a microvolt. They aren't the best squelch in the world on these, but that's very competent. And there we are, we're done. So, spent a lot of hours on this, and I mean a lot of hours, like about 6 of them. And then it turns out that the problem's those coils. So that will be interesting behind the scenes what I find out. So we'll just pop some case lids on. I reckon, as I say, that this has been faulty from new. Oh, it's not the right case, is it? I've just pinched them off a York 861, which is what I've just borrowed the coils out of. A working York 861. That's why we have these sets. That's why we have the demonstrators, so we can do things like this. There we go. Now there weren't many case screws. I'll assume he wants to buy some. They're all of 6p each. I dread to think what his bill's going to be with an audio RC and a genuine output transistor. I think that output transistor was £6.60, and we can all look on AliExpress and YouTube and eBay and that and find these transistors for 10 for 89p. But I can assure you they're not genuine. I think it came with 3 screws, but I've managed to find 4 on my bench without having put any new ones in. Put the circuits on one side. I've got a Midland 76900 base station to start next, which will be tomorrow. We've got a Uniden 200 in for repair. We've got a couple of Midland 771. No, what are they? Those 77805s, the transportables which have come in. So there's some interesting stuff. Now I've bought the 76900 base station myself. We do have one, because I used it to mend one the other week, which had had the kiss of death with it being 80 channeled and killed in the process. And so you've already seen that I've got one of those, and what we're going to do is this one has arrived with a box, so I'll keep that on the shelf. And what we'll do, the existing one we're going to use as our test base station. You know, when we do the on the air videos, we go over to the base station, which is a Harrier CBHQ. We're going to change that from Midland 76900, which is the one which is already here, and of course it's exactly the same innards. There's no performance difference at all, but I want to put the Harrier in the chapel we've had built, and save running back to the house if somebody calls me. We have the radio, as you know, coming over the tannoy system. I was hoping to find some more screws, but I'm going to have to go looking for those. So we'll do the next bit with 4 screws and not to 8. Right, we'll unplug the test set and switch it off, save a bit more electricity, and plug in the aerial. We'll see if there's any good buddies. Usually swearing from Nottingham 35 miles away on the burners. One on a Roger. That's not going to happen. $19 a Roger. No, absolutely nothing. Right, we'll try and untwazzle the wires. There's a good word. I can't demonstrate PA because it doesn't have it. And we'll get the bench cookie under the set, ready for an on-the-air test when Mr. Chippy becomes available. So thanks for watching. Rather difficult to find job, which, as I say, I don't think this has ever done 4 watts, but it does now. Thanks for watching.